Hello and happy Station Monday. Today we are going to be doing three stations again, as per usual. And like the last couple weeks, we will start with a station that's doing something what we did last week. Then we will do a station that's introducing what we're doing this Wednesday. Now we're getting really close to the end of the year. In fact, our topic this week will be the last new topic we do this year. So we're really approaching the end of the school year here. It's very crazy. It's been a very different end to the year. I don't like it very much. Um, Now, what we're going to do first is practice finding the volume. So that's how much space is taken up of a rectangular prism. And we did this on Wednesday. We did this with counting the blocks and with using our formula, which is that volume is equal to, well, I'll show you on a shoebox here. Volume is equal to the length, I guess we call that width, times length, times height. So one dimension by another dimension by the other dimension. Basically, what I'm really doing is I'm finding here, I guess I'm finding the length times the width. So that's the area of this face. And then I'm multiplying that by the height. So length times width times height, which gives us the volume, how much space this thing takes up. It's basically like how many of these bottom areas does it take to fill up the whole box, or how much water would fit inside of here. That's what volume is really asking. Now, what I want you to do is take a box, something like this. I said a Kleenex box, maybe, or a cereal box. I would like you to measure measure those three dimensions. So the length times the width times the height. Multiply those together and find your volume. Remember, volume will be in centimeters cubed or inches cubed or whatever your unit is cubed. Or if you're talking about in centimeters cubed, you could call that also liters or milliliters. Um, so that's what we're going to do for our first unit is measure some rectangular prism. So that's a rectangle with rectangular sides, a rectangular prism, and find the volume of that. That's your first activity, first station. I wish we could do that at the back table together. That would be the one I'd like to do with you. But that's okay. The next activity is going to seem a little bit more confusing because we haven't jumped into this yet. I'm going to just bring up a picture here. This is what we would call a coordinate grid or a Cartesian plane. And this is actually technically just quadrant one of a four quadrant Cartesian plane or coordinate grid. So it could do a whole sort of loop. We'd have a quadrant here, quadrant here, quadrant here, and a quadrant here, and that would make up the whole space of the coordinate plane. But as you can see on this screen, we start at the bottom left at the point 0, 0. And as we go further, I'm reflected here. So as we go further this way, we go up in our horizontal numbers. So 1, 2, 3, 4, 5, 6, 7, and on and on. And you could go on as far as you need it, as far as the grid extended. And that's our x value. So x is our horizontal value. And as we go up, we are increasing in our y value. So if we go up, we're going a higher number in y. If we go down, we're going a lower number in y. So we could have, if we're somewhere in the middle of this, like let's say that our point that that is we're asking what the location is this point here. Well, that point is, let's see, 1, 2, 3, 4, 5, 6, 7. It's 8 on the x axis, and 1, 2, 3, 4, 5, 6, 7 on the y axis. So we would call that point, let's do this in blue, the point would be 8. X comes before y. 7. Our point is the point 8, 7. Now, here's what I want you to do as an activity. Because we haven't actually got to practice this much yet, I want you to do something similar, but using a room in your house. And the precision on this doesn't have to be so important, but I'm going to show you here my living room, and I'm going to do that. So what I'm going to do is I'm going to try to locate this table here in terms of how many steps it is from my window here, my front wall, and from my right wall here. And I'll be able to tell you then what its position in this room is. So I guess I should turn the computer a bit this way so you can see me do the first one first. So from this wall, it is 1, 2, 3, 4 steps. So my X value is going to be 4. And this one's going to be harder to see because I have something blocking the way, but I'll still try to do it anyways. 1, 2, 3 steps from my front window. So that table in my living room is at the point 4, 3. So it would be like here, 4 steps in. That's the measurement I'm using. 3 steps up. So I would call that point 4, 3. Now that's what we're going to be getting used to this week, is how to point something on a coordinate grid. Now I did want to show you one more thing with this, though I hadn't brought it up, so I'll just bring it up here. Maps, google.ca. Now this is going to be an interesting way that this is used in real life. So this is, you can tell, a map of Edmonton. And I want to zoom in specifically on our school, on John D. Bracco. Let's see if it lets me do this. Oh, here we go. So here is John D. Bracco School. Now, John D. Bracco School is on 139th Avenue. And its address is actually 3150 139th Avenue. So the 31 means 31st Street and 139th Avenue. Now it's kind of confusing because 34th Street is kind of right beside it, but that's okay. Its address is 3150, so 31st Street and 139th Avenue. Now, if you were to zoom out on Edmonton, if we zoomed way out, we would see that the people who designed Edmonton initially actually had a sort of Cartesian plane in mind. Because if you go all the way down here, we will see this is 17th Street here. But theoretically, there's a street here that in some spots you can see called Meridian Street. It's like 0 on this side. But yeah, here is 17, and it goes up from there. So 17, 18, 19, 20, 21, and on and on. So that's the x-axis is increasing. And then as we go down to the south side of the city, we have a similar thing happening. As you can see here, it goes down lower than this, but here is 18th Avenue, 21st Avenue, 23rd, 24th, 25th, and on and on. So by the time you get up to Bracco, you're all the way up at 139th Avenue, way north of where this is, and you're west from 0. You're at 31st Street. And Edmonton goes about 215 blocks going east to west, so going from here all the way over to here, and it goes about 190 or so blocks going south to north in our northwest quadrant. So Edmonton is built on a coordinate plane also, same as the Cartesian plane, or how we would label something in a room or anything like that. And this is used in construction sites and in landscaping and all sorts of things, because it's nice to be able to make a reference of where you are talking about. So this idea, this coordinate plane, is used all over the place. Okay, well, have a fun time today doing your stations, and I'll talk to you guys at 11 o'clock.